All right, we are jumping into chapter 9. Chapter 9 is all about something called transformations. Each day we go through a different type of transformation, and then at the end we learn how to put them all together. So the first type of transformation that we're going to talk about are called translations. Translations. Know that it's not a translation from Spanish to English or something like that. Let's go ahead and jump in. Once again, we are talking about transformations. So what a transformation is a way of changing location, shape, size, or orientation. So just sliding, moving something would be considered a transformation. Flipping it would be a transformation. Rotating it would be a transformation. Making it bigger or smaller would be a transformation. Changing its shape would be a transformation as well. Does anybody have any questions about what a transformation is? What the preimage is it is the figure before the transformation. The way that you know it'll be that figure is you will just have normal points, like ABC. We'll talk about triangle ABC, and there's nothing fancy about it. That means it is the figure before something has happened. The image is the figure after the transformation happened. I'm being lazy and efficient by putting those in. So it's the same as preimage, but just after. The way that you're going to know that that's the figure when you've already done the transformation, mathematicians are crazy, lazy, and efficient. What they're going to do is do the least amount of work to prove their point. So they say A and they put a tick mark. That means the point after I've moved it. B, tick mark, C, tick mark. That's called prime notation. So if you see the primes, then you have gone over and already moved the figure or done whatever you needed. For example, if you had a triangle and we slid it over to here, then that would be ABC is where we started. Now it's A prime, B prime, C prime. And let's say then you went over and flipped it like that. Instead of A prime, B prime, C prime, think of a lazy way we could say that it changed and now it's changing again. What could you do? Two tick marks, A double prime, C double prime, and B double prime. So we use those marks to show kind of the progression of our transformation. Now, we're talking about a thing called rigid motion. The other word for rigid motion is an isometry. And what that is a transformation where the preimage and image are congruent. So there's many different ways you can transform a figure. Some of them you will end up with congruent figures. If you do, then it's called a rigid motion or an isometry. If you don't, then it's not a rigid motion or isometry. So when we look at this figure right here, CS, is this an isometry? CS.
Yes.
Is the preimage and the image, are they congruent? Yes, they just flipped, but they're identical in form. So this would be an isometry. You'll see this notation quite often. It'll be like triangle JKQ has mapped to, meaning it is transformed and is mapping to J prime, K prime, Q prime. This just means mapped to. Does anybody have any questions about what a transformation is or an isometry? No? Sometimes you're just going to have a slide. Like this one you can see flipped over a line. That is not what we're talking about today. This one we just went over and slid the figure. When you slide the figure, that is called a translation. So a translation is also known as a slide. In a slide, really what's going to happen is all points move same direction, same distance. just a slide. It's not rotating, it's not flipping, it's not doing anything other than just sliding. Any questions on that? So you can see this one is just slide, like a slide. It didn't rotate, didn't reflect, didn't do anything like that. LD, which figure would be the image after the transformation has happened? The black one or the blue one? Blue one, that is correct. So this one would be the image, and this one would be the pre-image. Okay, does anybody remember what thing goes over and talks about direction and magnitude, I believe it is? Vector. Fantastic. So here, one of the notations we are going to use, and for years this is plopped on top of there accidentally. The first method is going to be vector notation. How it works is the first number that goes here is going to be telling you how you're going to move left or right. And this one is going to be how you're moving up or down. It is going to be change of X and change of Y, basically. So this says that we have moved 4 units right. Well, to the right means positive, and since I went 4 units, I'm going to put a 4 there. That is how my X has changed. I have taken my point and I've moved it to the right on the X-axis, basically a distance of 4. Then it tells you it is moved by 2 units down, so that would be -2. And lastly, you tell me what you are doing it to, A, B, C, D. Anybody have any questions on that? That's called vector notation. We use that 90% of the time. What's up? The T is the mathematician's way of being lazy and efficient and talking about a translation. When we talk about a reflection, take a guess what they put for reflection. Great. How about dilation? Very good. You think like a mathematician, the least amount of work possible. The second notation you might see is they'll say, hey, every point that you know that's x, y, what I want you to do is I need you to take the x, and I want you to add 4 to it, and take the y and subtract 2 from it. And that would be notation number 2. Questions on that? Now there's something that becomes true about AA prime, the line segment, BB prime, and CC prime. So let's take a look at a translation and figure out what is true. I'm going to go from a point to its prime, a point to its prime, and a point to its prime. What do you notice about all of those line segments? There's 2 different things. So they are both going to be, they're all going to be congruent, and there's something else. What do you notice about they're parallel? So I'm going to be able to make application problems that involve AA prime for translations. This is for translations. I'm going to be able to make application problems where you need to know that they are congruent and parallel. Does anybody have any questions about what a translation is, how it's different than a transformation? Anything? Rigid motion? So let's go ahead and do one. When they give us these instructions right here, that tells us what we need to do to each point. Technically, you're going to move every point on here. There's infinitely many points, but really if you just move the corner points, that's enough. So what does that instruction, what do those instructions tell me to do? JL, what does this tell me to do? Up, down, left, or right? Left by how many? By 4. And then this one tells me to do what? We've already done left, right. So now it means up by 1. So you take each one of the corner points and do that exact thing. Go 1, 2, 3, 4, and go up by 1 and call that P prime. Go left by 1, 2, 3, 4, and go up by 1 and call it Q prime. Go left 1, 2, 3, 4, and go up and call that R prime. We talked about what a rigid motion is an isometry, no, sorry, is a translation in isometry in a rigid motion. Look at the pre-image and the image. Are they congruent? Then is it an isometry? Yes. Anybody have any questions on this notation right here where it tells you what to do to the points? Let's do another one. I need to know what the heck that means. GS. What is this telling me? What does the -2 tell me? GS. What does the -2 tell me? -2. Left 2. And what does the -5 tell me? Down 5. Does anybody have any questions on that? So you're going to take each of your corner points. Now, some people are like super lazy and efficient, and what they'll do is they'll do 1 point and then just redraw the figure. So you can go left by 1, 2, down by 5, 1, 2, 3, 4, 5. Is that where it is? Or is that? No, I think it's up by 1, isn't it? 1, 2, 1, 2, 3, 4. No, it's right here, huh? Okay, so that's the point, and that would be where R prime is. Now you can move all the rest of them, or you can just say if R is here, that's over 1, 1, 2, 3, 4. So you can go over by 1, 2, 3, 4 and put your other point, Q prime. And then you could say, oh, I went over by 1 and down by 2, over by 1, down by 2 right here. And that would be P prime. Question? That's, yeah, so you can do that. Once again, you can either take each point and do that, or you can just move 1 point and then be very, very careful drawing the rest of the figure. It's up to you. Anybody have any questions? Okay, what I'm going to do, and people who are watching from home, you're going to want to pause the video and give this one a shot. This one is that first note, or this is actually notation 2, notation 1. What I want you to do is be careful and go ahead and do your translation for both of those figures, and I'll be back with you in a moment. Okay, on the first one, you should have realized that that tells you how to go left or right. So you're going to go right by 4, and you're going to go down by 3. So if you take every single one of the points and go right by 4, down by 3, right by 4, down by 3, you end up getting this figure right here. Anybody have any questions on that? This one also has a left, right, up, down. The -4 tells me left by 4. The +1 tells me up by 1. So if you take all of these points and you do that shifting, this is where your figure ends up. Does anybody have any questions on that? Now what we're going to do is we're going to do the exact opposite thing. So we are going to put our big T, because we're doing a translation, and we know we're doing it to PQRS. Now we have to make sure, be very careful. Everybody makes this exact mistake. Figure out where you're going from and to. Since this has no prime, you are starting here. And since that has a prime, you're going to there. It doesn't always go left to right. It's not always going to do that. Sometimes the right figure will be your original. So if we're going from P to P prime or S to S prime or any of the others, how much to the right did I go to go from P to P prime? 1, 2, 3, 4, 5, 6, 7. Okay, that's 8. So I went 8 to the right to go from P going to P prime. Okay, and now how much do I go up or down? -2. Now, if you went the exact opposite, if you accidentally thought that this was the original, even though this is the image, if you thought that was the pre-image, you would have gotten the exact opposite answer. Now, the other notation would be x, y. All of your points are now going to take your x value and add 8 to it, and your y value and subtract 2 from it. That is the other notation. Does anybody have any questions? I want you guys to try the same thing. People at home, I'm going to pause the video. You are going to do your 2 notations. Do vector notation for ABC, and then do the other notation for ABC. Now be very, very careful. Make sure you're going from B to B prime, or from A to A prime, or from C to C prime. Make sure you're going in the right direction. Give that a shot. Okay, so you got to make sure that you are going from the non-prime to the prime. So in this case, we are going to be going left. Left by how much? 6. And then we're going to go up by how much? 5. If you got the exact opposite, that's because you went from left to right. Well, that was true on the problem above. It's not true on this one because you have to look at which one's the prime and which one's not the prime. So right here, obviously, you get your x and subtract 6 from it and get your y and add 5 to it. It's basically saying if you knew what your point was, let's say your point was 1, 3, just take 1 and subtract 6, take 3 and add 5, and that will give you your new location. Yes, question. Any questions on notation 1 or notation 2? Okay, yes. Nope, that was just me making sure you guys understood that we're going in this direction. Okay, next. So this one says that here is our rule. -4, 1. What would be the slope of AA prime? What is slope? Slope equals rise over run. When you have this thing right here, does that tell you what your rise and your run are? It does. So you can pick any location. Let's call this A. To go from A to A prime, what does that tell me to do? Left by 4 and go up by 1. And that's where A prime is. So is my slope going to be positive or negative? Negative. Negative. Down by 1 and over by how much? 4. You got to be careful because if you don't draw this thing out, you're probably going to think that it was -4 over 1. But the first number here is left or right, which is also known as a run. The second number here is up or down, which is a rise. Does anybody have any questions about why this is equivalent to having a slope of -1/4? No? Okay, the next one. We know that AA prime, that line segment, and BB prime, they are two things. What were those two things? They are congruent and parallel. Now let's figure out which one of those we care about for this. Here is where A is. A is located at 2, 5. Here is A prime. It's located at 8, 13. That would be the line segment that connects A and A prime. Let's say here's B. I'm going to make it so that it's congruent and parallel. Here's B and here's B prime. And they tell us that that length is 2x plus 4. That's what this notation means. Remember, AB with a line segment means the actual segment. That means the length of the segment. So what do we care about here? Do we care about the fact that they are parallel or congruent for this problem? Congruent. Okay, well, I just need to know what this length is, because once I know that length, I can go over and set it equal to 2x plus 4. How can I figure out the length of AA prime? What formula helps me with that? Distance. So let's go ahead and do that. 2, 5, 8, 13, x1, y1, x2, y2. And then we can put this in here. 8 minus 2 squared plus 13 minus 5 squared, 6 squared plus 8 squared, 36 plus 64. So what is the length of AA prime going to be? 10. And once again, we know AA prime will be the same as BB prime. So we know 2x plus 4 is definitely going to equal 10. Minus 4, you get 2x equals 6, and x equals 3. Does anybody have any questions on how I did that? Okay, we got one last problem in 2 minutes. Yeah, what's up? Yeah, B prime up here. So our last question says if AA prime has that as its equation, meaning it has a y-intercept of 1 and it has a slope of 3. So A and A prime will be somewhere along this line. And here is where B is. B is at 5, 7. And they want to know what is the equation of the line that BB prime would be on. What do we know about AA prime versus BB prime? They are parallel. Okay. What are the two things you need to write the equation of a line? Slope and a point. So if this has the equation of y equals 3x plus 1, then what's the slope of BB prime? If they're parallel, then they have the same slope. If this is the equation of AA prime, what is the slope of BB prime? 3 is correct. And then we have our 0.57. And just as a little algebra reminder, all you have to do is write the equation with everything you have at first. We don't know the y-intercept, so we just leave that as plus b. And then all you do is sub in the points. You would have 7 equals 3 times 5 plus b. 7 equals 15 plus b. And what is the y-intercept down here for BB prime? 7 minus 15 is negative 8. So you get y equals 3x minus 8. Okay, your homework is that last page. Bare bones, it's only 5 problems. You have to do all of them. Thanks a bunch.